Here is an example of a voltage amplifier. The input fed is the signal VIT and the amplifier is connected to a load resistance RL. This figure shows the transfer characteristic of this linear voltage amplifier having gain AV. What we must ask is how exactly is the amplifier able to increase the output voltage? To understand this, we must think in terms of power. The amplifier is always fed by one or two DC power supplies. They give extra power to the load and also the power consumption in the internal structure of the amplifier, such as heat dissipation. To understand this, take a look at this detailed version of the voltage amplifier. It requires two DC sources. Two terminals of the amplifier, V positive and V negative, are connected to the sources as shown. We wish to find the power delivered to the amplifier. Recall the equation for power, P is equal to VI. We need to consider separately the power each DC source delivers to the amplifier. Hence, PDC is equal to P1 plus P2, where P1 is the power delivered by V1 and P2 is the power delivered by P2. P1 is equal to V1 I1 and P2 is equal to minus I2 minus V2. This is because current is flowing out of the amplifier and into the negative side of V2. So PDC equals V1 I1 plus I2 V2. Now let P dissipated be the power consumed by the amplifier, and so we have where Pi is the power drawn from the signal source and PL is power delivered to the load. We can neglect Pi as it is very small, and so we have amplifier efficiency as eta is equal to PL over PDC into 100. Now this is an important parameter for power amplifiers.